and by pi to 2.
Okay, good evening everyone. So welcome to the day 2 of generative AI and deep learning. Yeah, good evening, good afternoon, okay, whatever it is. So welcome to all and welcome to the session. So last class, day 1, everyone we have to discuss about the particular thing, that is day 1 concept. So what is generative AI and deep learning, how it is work. So these kind of things we will discuss in lots, right? Today we can continue with that. That is today's concept is a leaf disease detection. Okay, so what does leaf disease detection means? So with the help of the deep learning, how can we detect the leaves? It is present it is affected the disease or not? Okay, so how much of the particular plants is having disease? Or just a minute. Yeah, okay, sorry, so some technical issue. Okay, so now I have to continue with that. So already day 1 presentation and source code, everything I have shared in a group, so kindly check it that. And some people will raise some kind of issue, that is I can't open the PPT, there also we have to replace that. So we can once check it that. So now we have to continue with that. Today's concept, what is deep learning? So deep learning foundation, how it is work, this kind of thing we will discuss. Then we have to go on to the leaf disease detection project. So once I explain the code and run the code each and every cell wise, how it is work, I give an explanation. Okay, so now entering the topic, that is deep learning. So already we know about that deep learning is one of the subset of machine learning. It is helpful to and handling the image or video related data. It is special to handling the every data. That is the deep learning concept. And deep learning is a subset of machine learning that involves the use of artificial neural network to model and solve the complex problems. And also this neural network are composed to many layers or interconnected nodes which allow them to learn increasingly sophisticated representation data over time. So already we know about the deep learning is working like a human brains concept. So here the neural network to handling the data in by layer, it is analyzing the data. So it is fit for us or to apply this kind of particular feature to our model. So here in final layer will predict that. So this is our feature or this is our exact data. So this kind of way the particular layer will be identify that. So last point is the deep learning has been used to achieve the state of the art research in a wide range of field, including computer vision, NLP, speech recognition, and robotics also. So this is the way the neurons is working like that. So what about neuron means, already we know. So the neural networks, the data is converting into the neuron format. It is passing the data in passing the values in every layer. So the neurons is splitting into the starting from the x1, so one neuron into the n number of neurons, and so each and every neuron is passed to the every cross layers. So first neuron is moved to the first first layer and the second and the third. So every layer is also cross over the data for analyzing process. Okay, here the independent input dependent variable 1, 2, 3. There is 3 kind of neurons is split here. So each and every neuron is also having kind of weight value. That means the particular neurons weight, the value will be splitting into layer wise. In that particular value is important for our back propagation also. So what is the meaning of back propagation? I will tell you later to in this particular session. So here in this neuron will be present in the every neural, every layer, neural network layer is having. It is helped to analyzing the data's feature. Finally, it is came out to the one kind of output, exact output variable. What is that object or like that. So this diagram is represent to the, so each neuron is having the one weight, that is weight 1, and the second neuron is having the weight 2 and weight 3, still the number of neurons. So here this formula will be applied for to analyzing the image to handling the weight values and same like as neuron values. So the activation function is having to deciding the if output is a binary or else a multi-class. So what kind of value we have, that means it is a single a binary value or multi-class value, so we have to fix that. So here the leaf disk detection is the multiple classes, like multiple leaves we have to use to predict the particular disease. So that is called as a multi-binary classification. Okay, simply said we have to multi-class. Next is a perception value, that is a formula, like the diagram wise every neuron will be working here. So X is having on the value, so first weight value is having the index number, so based on the index wise the every values will be applied in this particular model. Same finally the model will be extract the one particular feature, like output feature, to showing to us. So it is a diagram of neural networks. So starting from the input layer, and hidden layers is having the neural network CNN or else AN. So what kind of network we have to use, that is represented here. Finally the data will be extracted to output layer. And next one, it is neural network. So what is exact meaning of the neural networks? The neural network, it is a neuron is basic unit that receives the input from other neurons and are form of external data, process the input and produce the output signal. And the output of the neuron can be connected to the input or another neuron, forming a neuron of interconnected with the particular recognizing the pattern. So based on the pattern wise, data will make the prediction, and decision also included here. A typical neural network, artificial neural network, consists in the input layer, the hidden layer and output layer, supported by the activation function, loss function and optimizer. So optimizer is a pre-trained model for deep learning concept, and activation function is helpful to understanding the particular output, that is it is a binary or else multi-class. So loss function is having based on the weight values reduction, like reduce the particular weight values, we have to apply the backward propagation, will do that or not, that particular decision we have to make. Okay, and next one, layers in neural network. So what is the exact work of the particular input and output and hidden layers? So first thing, the input layer is receive the input. To each input is represented by the neuron, and it is the number of neurons is input layer dependent on the dimensionality of the input data. So the hidden layers are work to learn the recognizing the complex pattern of the input data. So based on the neurons count and neurons weight wise, is recognizing the data, what kind of things is present in that particular in each neuron. So the neurons is previous layer to produces output that is feed into the next layer. So first layer we are extracting some kind of features. Next, the particular extracted features only it is passing to the next layer, like feed into the next layer. That is the represented here. Based on the hidden layers is having working like the same format. The output layer produces the final output of the network, which can be prediction here, classification or some other type of output. So what kind of output we expected, the particular output layer will handle in the finalized one. So next one is a single layer neural network. See, mostly the single layer neural network, it is used for the text prediction only. It is not fit for our image prediction. The text is easily convert the values, and also it is one-way process. No need to the backward propagation. That means reverse process is not needed. It's a single-way process. We can pass it over data. The single neuron will pass into the every layer neurons. Easily it is find out the data extraction, because the comparatively the image and the video data, comparatively text is very easy to identify the particular value. So next one is a multi-layer neural network. So it is using for image or audio or video related data. It is mostly used for this kind of multiple layers to handling the particular exact data. So what happens in neural network? So we know about that. So input is having on particular neurons to the data will be stored in that particular neuron value. In every neuron is passed into the particular first layer. The first layer will be identify the weight value of the particular each and every neuron. So x1 is one of the neuron. In that neuron having one kind of weight value. The second neuron is also having the second weight, that is weight 2. The W is represented to the weight value. So this both are entering into the bias. The bias, it is the balanced value. Like balanced value means in every layer is passing to the one by one. We have to last value, right? Or else if we have do any kind of product or any kind of things, definitely we have to last some kind of loss. It is included to the stock market or starting from the productivity. So every places it is fit, right? So same like here also some values will be getting lost. So we don't need to much loss is not fit for our prediction. Okay, so because of the data's values we reduced by the only 0.2 value, it's enough for our loss function. So the activation function will be predicted. So that before now I said the activation function will be decided to that it is a single class value or binary class value or multi-class value. So what is the weight? The weight is represent to the strength of the connection between the neurons, and the weight is a scalar value that multiplies the input of a neuron to produce its output, and a bias is scalar value that is added to the weighted of the particular input to shift the activation function at the neuron left or right. So together we weight the biases control the behavior of the neural network and are adjusted during the training to optimize its performance. So we have to finalize the particular output feature. We can get in one kind of idea, that is multiply by the weight and the input adding of the bias value. That is our y, that is our output value exactly. So based on the loss value and also weight value and the input value, we have to sum of this kind of things. Then only we have to get one proper product, like the proper object to predict that. So the activation function is help to apply the mathematical equations to determine the output of a neural network model like yes or no. So just now I said the activation function help to predict the value, that is binary or multi-class. Based on the class wise it is predicted, it is yes or no or 0 or 1, like that way. So you have to select the activation function based on the problems. Sum of activation function is used to sigmoid, ReLU and softmax. And the sigmoid is based on the 0 or 1 value, and the ReLU it is mentioned to the binary 1, and the softmax is mostly used for the multi-class classification. So each and every function is having the individual work, the activation functions. The sigmoid, ReLU and softmax, it is called as an activation functions. And the next one, it is a weight, bias and activation function. So already we discussed about it. Now it here represented to the diagram base. And so now the first neuron will pass into the layer. So in between the process we can get into one kind of bias value. The B1 is a bias 1 value. So here we can get the 0.45. So just an example, that is 0.45. It is one of the bias value, that means loss value. So again it is move on to the next layer. Here also we can get some loss value. So based on the loss value and also extracted value, comparing with that and also sum up with that, we can get into one proper output. Okay, so next one, it is a forward propagation. So forward propagation means our as usual work. First we have to do one kind of process, right? The input like a prediction process, that is called as a forward propagation. It is the process of passing the data through a neural network to produce an output. Okay, that is our normal ordinary work. So the backward propagation, it is a reverse concept. So once we cannot get a proper output in the particular final layer, we have to do with it the reverse propagation. So again the output layers is reversely going to the third hidden layer, again going to the second hidden layer, again it's going to the first hidden layer, finally it's reaching to the input layer, again it is do that in a starting process. Forward propagation again we have to apply, then only we can represent to that it is a forward propagation. So loss function. A loss function is a mathematical function that measures the difference between the predicted output of a machine learning model and the actual output. Okay. So then only I said the Bayes and the loss is so based on the each and one layer to another layer passing values, we are getting some kind of reduction that is called reducing. That is called as a loss function. So the comparison will happen to the exact output and also predicted output. So the back propagation, the weight and the bias are adjusted based on the error between the predicted output and the actual output. It is work by the propagating the error backwards through the network, starting at the output layer and working at the towards the input layer. So here we can see just now here the backward propagation will happen. So once output layer is here, again it's go on to the hidden layer, third hidden layer, again it's go on to the input layer. So again it is due into the forward propagation. That time we have to get it on proper output because every value is move on to the reverse. That means the last value is also combined with like added with the extract feature value. Okay, and how the weights and the bias are adjusted, that is only we have to know. So optimizers are algorithms that are used to adjust the weights and the bias in a neural network during training with the goal of minimizing the loss function, and the weight and the bias are updated via the chain rule of differentiation. So optimizers is used to hyperparameter known as a learning rate. It is used to control the step size during the optimization. The ultimate goal, the optimizers is deep learning, it minimizing the loss function. So why we have to using the optimizer? Now you understand. So the optimizer is help to minimizing the loss values. How based on our training process, how we can getting the less loss value, then we have to get the proper output and our predicted values also comes well. Okay, and so this is the way the gradient descent. So we have only one Adam optimizer, we have to do that. So based on the topic wise, we can using the optimizer will differ. So now it is known, gradient is known here. Now we only using the Adam optimizer. So now it's known here. In upcoming project, we have to discuss about this particular gradient optimizer. Okay, so now this is no needed. We have to confuse thing. Okay, so now we are using the deep learning to predict the particular leaf disease. So we have to use only particular model only we have to discuss. So first one, forward propagation, next backward propagation. It is starting the process of input multiplied by the weights plus bias will be sum of the values. Next is going to the activation function. Once we cannot get the proper output, means we have to go with the backward propagation. So again output, then we have to go with the loss function, again go with the optimizers. Finally it is going to the input layer, that is a new weight and the new bias. So every time the values will be add on to the extracted feature. So that time the value will be changed. Okay. Okay, so before that I will show them an example, then only you can easily understand, like demonstration about this. So like okay, I think you don't have a whiteboard on it. Okay, so now we can see here it is starting from the one input layer, and also second one is an hidden layer. Here this hidden layer is there. Here's a hidden layer. Finally it is the output layer also here. This is our exact output will be there in this place. So first of all we have to pass it the input. So input layer. So in this input layer it is getting some kind of neurons. So it is represented to the neurons way. So in this every neurons is passing to the crossover, like cross and trophy, like that means cross the every neurons passing into randomly assigning the each and every neurons. So this is the way every neurons will be cross value to passing the every layer. Here the each neurons having getting the weight value. So it is a weight 1, and again this one is a weight 2, This one is a weight 3, and again it's going to the here now, so weight 4. So it is the first weight 1, weight 2, weight 3, weight 4. Again it is the second neurons having, so each neuron having the multiple weight values. Okay, so the first neuron, we have to represent to the neuron 1, it having the weight 1, and neuron 2 having the weight 2. Same like that, neuron 2 having the weight 1, 2, 3, 4. How much of the cross values will be there? We have to represent the weight value also based on the each and every neurons. So same like here also, here one kind of data like feature will be extracted. Okay, so here also some features will be extracted. The extracted feature will be passing into the another layer. So that is a here like the same format is passing to like here. It is randomly splitting to the multiple places. So in this every process will be done, so the each and every layer will predict the one particular feature. Here also one thing. So again it is cross. Finally output layers will comes into the one value only, 1 or 2 only, it is comes to the output layer. So here also one kind of feature is there, right? So based on the image or based on the data object type wise, it is classified the one main or major value neuron will be there. So in this particular 4 kind of objects will be there in each and every neuron. So based on the values wise, so in here is 0.7, I think it is a 0.7, and it is a 0.5, and it is a 0.3, and it is a 0.1. I think it is properly not showing. It is 0.3. So in this particular 4 neurons, we have to get it the maximum pooling layer. We have to apply the maximum pooling layer. In that layer is a layer to deciding that particular based on the neuron count wise, it is extracting the exact output. And also in between the process, the activation function will be applied. The layer is differed based on the project wise. So softmax binary classification means we have to use the softmax, or multi-class means we have to use the softmax. Binary means we have to using the ReLU, and what is that? Single layer means we have to using the threshold. So based on the type wise, we have to defer the activation function. Okay, so once we cannot done a proper way, like proper output means, again we have to go with the again we have to go with that reverse propagation. So now it's going to here. Again the data will be passed into this particular one. In here from it's going to the second one. Again it's passing to the first layer. Finally it's going to the input. Again the reprocess will be there. The forward propagation is there. It is a backward propagation. Okay, I cannot write in digital one. So backward propagation. Once it is go to that, okay. So now again it's about forward propagation is happen. Once backward will be done, again it's move on to the same process that is called as a forward propagation. Okay, so this is the way the every process will be there. So now I have to go with that slide. Okay, so now we have to go with the types of activation function and the loss function of optimizers, and how to select the activation and the loss function of the optimizers. So there are 6 kind of activation functions are there. One is a sigmoid, tanh, ReLU, and a leaky ReLU, softmax, and a linear. This kind of 6 kind of activation functions are used to based on the type wise classification type wise. First one is sigmoid. So sigmoid already, I think, yeah, sigmoid already we know it is a 0 to 1s. So based on the in between the value, it is also related to binary classification. I mean it is this or that. So if only do 2 object means I have to predict the one kind of single animal object or single object. I have to pass it the dog image, Finally, the based on the features wise, the model will be predict it is the two kind of values. One is a dog and a cat. So our prediction is dog, because of based on the features wise, it is predicted the two different objects. So we need one exact thing. Okay, that is our dog image. So based on the maximum value of the particular object, it is extracted that is dog. Or else we can say it like that. So 1 isn't the exact output, 0 isn't, it is the similar output. We can say it like that. That is the sigmoid activation. Next one is a vanishing the gradient problem. So sigmoid and derivation of sigmoid. So the sigmoid is an exact value. Derivation sigmoid is an approximate value. And tan h function is help to identify that it is same like that. So it is a 0 to starting from minus value, negative value to positive value. So tan h we cannot using here. So we only using the activation that is a sigmoid or else ReLU or else softmax. So in this leaf district we have to using the softmax. Okay. So ReLU also same like that. That is maximum value. We can get it that. So based on the features wise, just now I said. So we have to get it in multi classes means we can get the multiple values. So starting with the example 0.2, 3 or 5 and 7 like that. So our exact output present in the highest value. That is the 0.7 is then I have our highest value, right? So we can get it the highest value, that is maximum of exact output. X is an actual output. Our predicted output is an another value, that is 0 or 1 or 2. That is that our getting value, it is a predicted value. So leaky ReLU also same like that. We have to multiply by the weight and bias. That's it. So just now it is a softmax function. Here also same like that. Some multiple classes. So already we know about that output layer. So that is actual output already we know, because of human we know about that. Our model will probability is our predicted values. Output layer is getting this kind of values. 1.3, 5.1, 2.2, 0.7, 1.1. Based on our optimizer and also our model wise, the model will be predicted this some kind of probability values. So in this particular comparison to decide the value, it is right or it is our exact thing or not. Here the 5.1, it is a output layers, the value is here. So our thing, our exact output value is 0.90. So both are equal. Here the point values are there. It's a 0 point value is there. So 1 point value is here. So you can see the second index, both are having the highest value. So here the 5.1 is an exact actual output. Our model also predicted it is a 0.19 is a maximum value. In the second index, same second index also, our predicted value is presented. So now based on the applied steps, based on this applied formula wise, we have to get the proper output of our exact prediction. So this is the way the softmax function will be applied, like extracting the exact output. Find out our predicted output. So the linear activation is also known as the no activation or identity function. It is multiplied by the point values and is where the activation is proportional to the input. Wait a second. Okay, sorry. So the function does not do anything to the weighted sum of the input. It is simply gives the value it is given. It's not calculated the loss value and the bias value. That is the linear activation will be there. So what exactly the particular features, layers will be extracted value. That one value will be stored into the another layer. It is not taking the weight value, like consider the weight and the loss to apply our predicted one. So next one, loss function. So MSC MAE, that means mean square error, mean accuracy error. So the loss function means the loss value is having one kind of names, the function names. So mean square error and mean absolute error. So mean square error is applied to this kind of formula. So no need to worry about this formulas. It is just that we know. So this kind of formula will be applied in the beginning the process. So we don't know to apply it manually. So once we have to create the code line or command, automatically the formula will be applied in the begin the process. This is a MAE, like that, mean absolute and mean square error. And binary cross entropy, this is the formula to apply the binary cross entropy. And the categorical cross entropy also same like that, that is multiple values, like multi-class classification. Here we have to use this particular loss value function because our list is in multi-classes. So optimizes only gradient and Adam, already told this. Here we have to using only Adam optimizer. So gradient will be we can discuss about it later. Okay, so not now. So gradient is known as Adam optimizer. So Adam is having these two kind of formulas will apply to analyzing the particular data. So V at VT and VST. So B1 is multiplied by the VT means, so each and every value is having one kind of meaning. So the N is represented as initializing the learning rate, our model to accuracy prediction, and the GT is a gradient at the time at along, how many times it take to predict the each, like train the each epoch, and V1 is an exponential average of the gradient along with that new values, and ST is an exponential average of squares of gradient along with that exist value, and beta 1 beta 2 is a hyperparameter, that is the default ones. Okay, so now this is the basics of a deep learning function. So this kind of process only we have to implement in a leaf disease reduction also. So now directly we have entering into the coding to predict the particular leaf disease. Okay, I think I already done this upload everything because it is email data and also it takes too much time, and only I have to already done with that process and everything. Once I explain this flow code and run the cell each and one by one, I have to find out that. So just a minute. So okay, so now everyone can see my screen, right? And okay, so here okay, so in this process voice is not coming. Now it's okay. Now it's okay or not? Okay, fine, thank you. So now I have to continue with this. Okay, so okay, thank you for your response. Okay, so starting with that, I have to upload my data set first of all. Okay, so you already have the data set. Once I show that, yeah, I have to go with that file manager. I'm just showing to you. Yeah, okay, fine, nice. Have to give it, okay. I think it is image data, so it is takes too much time to extract that. So only one image will be there, like one folder only extracted here. So now you can see this, that is the pepper, but that is the first one. It is having some kind of disease. You can see it here. So here the affecting one disease will be affected based on the particular plant. So each and every image having the particular training purpose to affect the different kind of images. So this every leaves represent to the pepper bell. This is one of the leaf name. So again the pepper bell healthy is here, pepper bell bacterial spot and the blight. So early blight. So based on the individual fruit individual vegetables leaf, it is updated one by one, because it is now still the file will be extracted here. So 10% only it is completed, only it is happened. It's take too much time, so we can go with that code. Okay, so here I have to show the particular image. I try to show. So here you can see already uploaded, right? So first one is the bacterial pepper bell bacterial spot, second one is a healthy spot. So you can see, so in this one it is a healthy leaf. So pepper bell, the particular plant leaves, it is a healthy one. So another one is it is an affected one. Okay, so now is everyone, you have to upload the zip file, right? Zip file format. You can see, oh sorry, so here the achieve one is a zip file. I already, there is so much kind of data, so it is extracted, still it takes some time. Then I directly upload the zip file to create a coding for the extracting some kind of files in upload in the same location, in Collab notebook location. So once I copy the path and paste it here, once I upload the achieved zip one, so the command is the import zip file is a library, and with the zip file, dot zip file is to extract this kind of URL zip file and extract from the zip format. So zip file dot extract all, and the content will be created in the particular URL. The extracted data will be stored in this particular URL. So once I run this cell, so already it is uploaded in the file manager. So already it is uploaded here, so it is no need to upload again. Okay, when it is done means then we can go with the next one, that is important libraries we have to import. So import torch, so torch vision, and also torch utils, and pandas, numpy, matplot, and c1. So this kind of 4 libraries already we know about that. So most of the people you know about this because of it is a basic machine learning or else Python libraries. And same like us, this another 4 is our using purpose. So data torch, it is already we know the PyTorch is mostly used in this particular deep learning concept, and it transforms, it is help to the data like image data into the text format. Torch vision is help to get it the other utils to extracting the particular libraries or functions. And again the data was loading to our data loader, that is help to make the images like the text images stored into our model. So these are the libraries is enough for us. So pandas as the pre-processed library, we have to upload into every process, and numpy is handling the numerical values, and matplotlib and cbond to create the frame, like we need to apply the heat map for our understanding. So the cbond matplotlib will help to create the image and also plotting, so everything. So once I run this, then I have to go with the transformers to resizing the every image into same equal size. So transforms equal to transforms dot compose the image into the 32 cross 32. That is the pixel size of this each and every image, because each image is having the different high kind of like high amount of pixel values. Something is a low amount of pixel values. So if we have to equalize that, then only I have to give the resize of this 32 cross 32. Then have to train and upload the model. So train data is equal to torchvision dot datasets dot image folder. So I have to paste it the exact folder. Once the zip file will extracted, it is going to the plant village. That means another training data. Okay, this is the training data. We have to upload this path here. So I have to upload, then that using the transformers and place it here. Because of already we can resizing the transformers model, right? So we have to implement that. This one also we have to run. Then okay, I have to training the data. So once I executed this, we have to see what kind of data we have to pass, how many number of data points we have, and so everything will be fine or not. So around 20,000 images we have. So this is a count of the data points, and the root location is our URL is represented here. The standard transformation is the 32 cross 32. So maximum size is not represented here. So once I run this, that also executed same thing, 20,000 to 632 images. Then class index of the each and everything. So first one is already we see about it here also. The first place having the pepper bell bacterial, second one is healthy, third one is yearly blight. So same like that here also, the pepper bell bacterial spot is present in the 0th index, and the pepper bell healthy is in first index, and based on the image ordering wise, the index value is represented here. Totally the 14 kind of folders it is presented here, and each folder is having the around 1000, so like that way it here. 14 images is there, like folders is there, and testing data also we have to separately have, right? So that also I have to represent it to the. So this is the testing data. It is a training data and this is the testing data, right? Yeah, right. So I have to copy the path and paste it here also. Oh, sorry, I have to give it proper wrong one. So again, I tested the data, that is 2368, and 32 cross 32 is here. So next I have to pass it the both of it into the data loader function to upload that train loader and the test loader. So both is needed. So training data also we needed, testing data also we needed. So I have to upload this training data. Batch size is the 32 batch. So each batch is having the around 256, I think, right? So we have to see, right? So next one I have to get a sample of this each and everything. So next of the iter tools to help to find out the shape of particular thing. So train that loader we have to pass it train data, and 0, 0 it is permute the particular data in 1 by 1, iterate the particular data 1 by 1, and permute value is starting to 1 and ending to 2. The value is speed. The speed value is in 0. Once the sample dot shape is the each and everything is how much shape, that is 32 cross 32 of the third 3 kind of values will be identified here. And the page dot figure of function, the fix size is 1 cross 1, and show image im show it is to represent the image particular flower, leaf image. It is randomly get the particular image. Okay, if I run this, you can notice the values also differ, and the image also comes like into the different image. So next one we have to go with that OS, import OS. The training path we have to represent here. Already we got a training path, training path. Trainer dot class index, already we have to find out the index, bacteria spot, healthy one, Index value already we know about that. And healthy one, it is okay. So here I have to identify the healthy values are separate folder and disease value, I mean disease leaves are separate folder. I need to classify the both in individually. Okay, so for D in os.latest, so the for loop function help to separate the each and everything into this single each folder. So already I have to create an empty list for the empty folder, and the for loop to help to create the each and everything in separately. So D is an iteration variable, and in os.list directory, that means based on our okay, so based on our image path, so based on this kind of URL path wise, have to extracting the images. So temporary file is equal to d.split, and based on the space wise also. So if the condition is health, means we have to store it into the healthy, like healthy folder, like healthy list, or else it is disease, means we have to go with a disease folder. Then we have to represent that D. Why the D is represent means the D is an iteration variable to store it, like extracting the each and every image and storing the class into the individual folder. Okay, once I run this, it is a behind process. So now I check the len of healthy, means it is 2. Same like the len of disease is 13. So totally the 14 the folders, the 2 folders only having a healthy one, and another everything is in it is affected, like diseased one. So you can see healthy, and also tomato is healthy is here. So I think not another thing, it is not have a healthy one. So in this particular 14 folder, the second index and the 13 index also, 13 count of index like folders is having particular healthy and also disease. So next we have to extracting the count. So based on the image wise, sir. So image. So now we can see. So already we have a individual folders. Okay, folder wise we have to separate the kind of images. So pepper bell bacterial spot, means that is one of the healthy one. Okay, you asking to, it is a second one, I think second index like that. No, so no. So totally 3 kind of folders is having healthy, right? Yeah, right one. So pepper bell, yeah, it is healthy one, and also potato is having healthy, and tomato is healthy. Still the 3 kind of values is having the healthy one, right? So but it is represent to the 2. Yeah, nice one. Okay, I think maybe some folders is missing, some kind of happens is there because of our so because of our prediction is only we have to do the prediction, so we cannot do the exact answer. Prediction means approximately the values will be there, right? So maybe a model will be less prediction, a model is not trained well, this kind of processes happen. Yeah, right. So only we have to check, okay, or else I have to correct it, try to correct it and share the code into you to your before I have to correct that. And the count of the data frame of the is, so PD is in pandas. Already in before that we have to upload the one kind of library, that is pandas. So pandas PD to execute the create the data frame. Well, yeah, okay, there it is. Yeah, already we have that number of images based on the folders wise we have to get the number of image. So we have to create into the data frame format, that is easy to classify and to find out the images. So pd.dataframe of count.values, and index is count.keys. So based on the keys and values wise we have to represent that, and the column name is number of images. So only one column we have to know, so another we will, it is represent to the folder name. So once I run this, again I run this one. So folder wise, so pepper bell healthy is having the 1478 folders also there, and tomato mosaic virus, that is having the 373 images presented here. Tomato bacteria spot is a 2000 count. Potato late blind is a 1000 count of images in present in this particular folder. Tomato early blind is having the it is also 1000. So individually it is having the individual count of images. So next one, so device, we have to check it our hardware unit. So device in our system is CUDA format or CPU format, whatever it is. Based on that, it is we have to check. So device equal to CUDA means it is a CUDA is available, we have to represent, or else it is CPU to represent here. So device is a CUDA format. Already I changing the runtime into the T4 GPU. So here the T4 it is most faster to CPU. And C is equal to 0 means we have to identify the is a 0 or 1 format like index y. So for x in train loader, C plus equal to 1. So in, the values will be represented to the 1 by 1, like 0 and 1 means x0 dot 2 device and x12 dot device. So how much of 0 and how much of 1 we have to classify that. So totally 645. Okay, so we have to wait for this. So kindly wait, it will take some time to executing this cell. Okay, once it is done means the C value is having the 645 indexes and 645 images only, it is properly executed. So we have to divide the particular every images into 2196 in which one? Code 73. Here it is not the 73 cells. Which one you ask? Sandeep Kumar Gautam. C is equal to, oh, okay, fine. Yeah, okay, fine. So C is equal to our temporary variable. Okay, so C is equal to 0 means we have to initializing the 0th value. So for x in train loader, so train loader is our training data. So in that particular training data, we have to classify the 0th index and the first index. Okay, so C plus 1 is equal to the 1. We have to identify the assigning the data 1 by 1. Okay, so C plus equal to 1 means starting from the 0th index, every images will be adding 1 by 1. So finally we got the one particular count of images to storing into the particular C variable. It is for our testing purpose. Here we have to extracting the images for our testing purpose. So already we have the train data and the URL will be there. So for our testing purpose, individually we have to make the images our testing purpose. That is, we have to store it into the C variable. So everything will be stored into the same device. Then only you have to classify into the 0 and 1s. So in the C variable, the 645 images for testing purpose we have to store in a C variable. Yeah, okay, fine. Okay, so it is how it is testing. We have to once feed it to our image. That means finally we have to create the confusion matrix. Okay, we have to create one confusion matrix heat map table. In that particular table, how much count of images is represented into the based on the index wise. For example, 0th index having the one kind of folder. In that particular folder, how much of images having the healthy, how much of the disease. So we have to classify that. So finally I have to show you the particular heat map. and we can try to create in this particular feed in the image it is affected or not. Once I have to adding the coding in this particular file, so I don't have a time to add. So before send it to you, I have to try to add the particular file in prediction format. Just how much of images we have to good or bad, like healthy or test, disease. So here we have to pass it our layers, so deep learning layers. So from torch and import neural network, create the class that is CNN module convolution neural network. We have to pass it here and pass it into the init function, that is a parent function to uploading our data in one by one. That super.init, it is a child function, that is a supporting function. Wherever the init function to struggle or cannot handle the data or layers means the init function to apply the another step. So self.block1, it is a sequential one. So in a neural network dot convolutional 2D, number of channels is 3 channels and out channel is 128. So that means input channel, output channel. So each layer is passing into the 3 kind of layers in one layer. One neuron now came out from the one particular neuron, it is come out from the 128. So another neuron, another layer to handle in the 128 neuron at that time. So the kernel size is 3 cross 3. That means the size of this particular neuron, that is 3 rows, 3 columns, like that way. So the padding is 1 meter only, it is needed for the each and every neurons. And ReLU is a leaky ReLU to assigning the function. And the batch normalization is a 128 one. And the maximum pooling already we know. So which one is high amount of neuron, that is our exact feature to pass it to the another process. So next block 2 is also same like that. Here that is a new and next layer. So cell block 1 is the first layer, block 2 is in second layer. In the second layer is having 128 is in the next layer is getting the input, that is 128 layers. The output values is a 256 layer and the kernel size is a 3. So every neuron is handling the 3 kernel size, that is means the box size. Wait a second. So it is a kernel, right? So in this kernel it is getting the 4 kind of neurons or 3 kind of neurons. So it is one value 2 or 3 and 5, like that. So in this length and width it is called as a 3 cross 3 or 2 cross 2, like that. So it is a kernel. So same like that kernel right now. So 3 cross 3 means okay, where is that? That means 3 rows and 3 columns is here. So in this 3 cross 3 means, so here 3 rows and 3 column. In the individual cell it having the particular neurons. So here is also 5 and it is a 6, it is 0 and it is a 7 and it is a 4. So based on the kernel size, the neurons will be represented into the particular place. So it is one of the neuron, it is one of the neuron, it is one of the neuron. The values have to represent that. So there are also kernel size. So because here we have to using the image, so I don't have the particular slide in this particular concept. So in next session I have to showing the one particular image, how the image, the image is splitting into the kernel size wise. I have to show you. And the third one is having same like that. So finally it is drop out to the 0.1 or like that way. So third layer to find out the 256 into the 512, it is the highest layer. Here only our entire image will be splitting into the exact features. So finally it comes to the classification type. So the activation function will be there. In this place only it is applied the what is the exact object represented in the particular leaf. It is a healthy or disease. So dropout function is find out the 0.2, that is the values of, we have to compress the size. And flatten layer to find out, that is a single layer. For example, here I have to say it is a row wise column, multi-dimensional array wise it is there, right? So in case the finally it comes to the flattened layer means the flattened layer means the flattened layer is represented to the like this format. So one like this or like this. So in this particular 4 cell or 5 cells will be present in the multiple values. So it is present to the 0.1, it is 0.11 and there's a 0.19 or 0.2 or 1.5. So based on the values wise, the flattened layer will be getting the values. So finally the maximum pooling layer to get it the maximum value of this particular flattened layer, that is our exact output. That means the each image it is a contains disease one or healthy one. Based on the value wise it comes to the one kind of decision. So the linear will be multiply the particular extracted values. Finally it comes to the one particular output. So x4 is a final output layer. So x1, block 1, block 2, block 3, the classification. Finally x4 is the final layer, that means output layer. Here the model will be checked to the CNN, that is convolution neural network. We have to pass it here into our device. The cross entropy to assigning the optimizer to dot optimizer of Adam optimizer. The parameters equal to model to pass it to the 3 power e minus 4 and the number of epochs is a 5. So the learning rate is representing to the 3 to minus 4. In between the values the learning rate will be there. So each model, like each epoch to having the particular learning rate value. So the epochs count is in 5. That means the 5 times the particular data was trained. So once I run this, you can see this 0.003, that is our learning rate. So our model will be getting the learning rate like this. So it is a fixed one, we cannot change it this. And so next we have to finalize the accuracy score and the confusion matrix. So it is a model training purpose. So the scale and dot matrix and accuracy and confusion matrix we have to implement here. Model to dot to device for epoch in a range of epochs. So each epoch is starting from the finalizing the n number of epochs. I have to fix in the 5 kind of epochs count. So based on that the training will be there. So based on our features and the train loader, training path and everything will be stored into our model training to execute it one by one. So based on the last function and the backward function is needed, we have to apply this, and the steps is to apply to the optimizer wise one by one, Adam optimizer. And the top feature value and target value, everything will be executed like one by one. Finally our print statement executed like epoch starting from the 1 to the last training will be there, and accuracy or testing our accuracy score. So already I run this one, you can see this, the last values will be 0.32, still it is decreased 0.01. The accuracy testing will be increased. Our accuracy value is getting high number of amount. So I run this. So every time the number of epochs will be there starting from the 0th index, still 4 wise it is there, epoch 0. So each epoch is having the 36 batch size is having. So once it is done, the testing is happened. So next format, the testing loader will be there. It is getting some kind of loader, how much testing there is. Once it is done means we have to implement the another one. So which one you have to ask to explain about that? So entire code or else each line? Okay, it takes some time, so it is have to execute it. So once it is done means we have to checking the testing loader, and testing loader is having the, it is a 0 or 1. So based on the healthy or disease wise it is a fixed the tensor range, The test data of class index, it is a plant village having 0. So there is nothing having into the particular index. Finally, the output is having the model, it is unsqueezed dimension in a single array. So 0 is represented to the single dimension array based on our CUDA device. The output size is 1,38. In single row, having the 38 count of images is there. And torch.argument max. So argument max function to apply the softmax. So we have to multiple classes. So find out the class, it is executed. Finally, the features already we can get it the 512. That is our maximum level of feature extraction. So multiplied by the 4x4 means it is getting the 8000 image. So around 8000 is a testing one. Okay, now it is done or not. So still 0th epoch only it is completed. So loss on training is a 0.2 and accuracy testing is a 0.9. Still we need to decreasing the loss value, then only have a prediction will be that it is good. The loss value have to decrease and the health value, accuracy value has to have to increase. Based on the accuracy value, our model is predicting good or not. We have to come to one kind of understanding. So finally, next one, the model evaluation. Finally, the every process will be there. We have to check it one kind of thing. So model dot evaluate and the all prediction and all product target will be assigned in this empty list. So based on the previous steps, we will apply it here also. So for based on the feature value and target value, and if test loader will apply it here. So the feature value, target value, one by one, the device CUDA format wise, one by one it is applied it here. And the squeeze format also we have to apply based on the loss value and the predicted value wise. The softmax will be there also. It is deciding the index of the particular one. The accuracy score, all target and all predictions. Finally, the confusion matrix, it is executed the all target and all prediction. Based on that, how many images it is healthy one and this is one. We have to find out in the final cell. Once it is done, we have to go with the next one. Still it is epoch 2, second epoch is there. So we have to wait. So you can see now finally the output will be there. So every index is predicted in normally. So 0 cross 0, 0th index having the 967 in images. It is a well trained, properly predicted. So where will we have to see in the particular count of images? So we have to comparing the particular one here. So 0th index having the healthy one. In that particular healthy folder also having some kind of disease images are there. So based on the images count, it is represented into the particular place. So first index having the 1500 images is healthy one and others is an non-healthy. So like that way. So once it is previous one. Once the epoch will be done, again we have to rerun that particular cell. We have to see so what it is happened exactly. So still one more cell epoch is needed. So now you can see suddenly the loss function will be decreased in the third epoch. So the accuracy will be increased to still 9.97. So we have to see the loss training, loss value will be increased, means we have to again do that in a rerun process. Reprocess is needed. Yeah, it is now done. Now I have to go run this again. This also run it again. So T tensor is the third 3 index 3 kind of things, it is here. And class index, it is represented, the every index will be represented one by one. And output model sun squeeze wise, output shape, it is a 1 cross 32, same like that. The tensor value is a 3, the q die is 0, same like that. And the multiply by the value of extracted feature. And I have to run this model evaluation. So now we have to try to run into the particular accuracy of hundreds. Still it is executed because of the every process in a single place, right? So the values will be extracted and feature values and identify the predicted and loss value. Extend this one and make a decision in this. It is a softmax applied here also. So accuracy is a 97%. The accuracy will be there because it is a machine learning model. One kind of formula is there. It is above 70 means it is a good model. In between the 50 to 70, that is average model. It is a below 50 means it is a bad model. So we have to change the model, or else we have to change the process. So like that way. Here we can get it the 97%. It is a good model. So our model also predicted good. So once I again rerun this particular process, we can get it the proper figure out heat map range. So now you can see this. So every 0, 0. So in 0th folders, 995 images is a properly healthy one. Okay. And same like that, the others, the 338, 0.7, 7.0, 2.0, this is the diseased one. So comparing with that, another image is also diseased one based on the ranges of, based on the dark range wise. So the dark range is not, it is a good one, right? So again 1 cross 1 is having 1400, so remaining isn't affected or diseased one. Same like that, third one is also 9, I think it is a 900, right? So based on the value wise, we can say it is a good model. So you can see the 97%. Here also our accuracy will be there. The epoch, number of training epochs also, we can get it the 97, 0.9791. So our multiply the values into the 100, that also nearly 19 is, I think 97, right? So if we get in before that, I know everyone noticed this one. Before that, the 4 value only is there. That is very less because of it is a previous time we cannot train properly. Then only the 4 value will be there. That time the every process will be in the upside. So single what is that? Single folder only get it predict the proper value. So others is not predicted well. So now it is predicted equally. So based on the count wise. Sandeep sir, if you are asking, you have to inbuild this one in a mobile. So I think mobile we cannot do this because mobile is not having the CUDA option. I don't know exactly. So once you give a time, once I check it, it has happened to a mobile. So now better thing, you have to train with your system. Okay, so no need mobile. Mobile is not supporting for that much kind of data also. So now the accuracy will be there, the prediction also good. So each and every folder is predicted well. So starting the 0 to 14th index. So if I open into the new tab, so you can see this one, it is good to see. So equally it is predicted. In case it is not getting proper value, means it is before that you can see in a single row it is having the equally predicted. It is not proper prediction, it's not happen. Yeah, of course that's why I said it's take too much time and so much errors also we get it that. Okay, so that's it. This is the process. This is the way deep deduction will be there. So we have to create in this in image wise. We have to predict it is good one or bad one. You have to take the photo from your mobile and using this model, can we predict healthy or disease? Oh, you can ask, it is a prediction, right? So I understand. Yeah, I understand, sir. So that only we have to add it that. So based on the once the real time camera we have to fix, so pass it our image in that image isn't affected or not. So that kind of way you have to ask, right? So I understand this. This one also before that I said once I have to implement the particular some kind of adding some codings to add for the prediction. So once I add it that once I send it to you, or if you already know about that how to do that means you can try with that. Okay, so it is still it is getting error, then only I cannot do that in particular prediction. Anil Kumar sir, what you said, diagonal one is missing. What sir, I can understand what is diagonal. And Sandeep Kumar sir, I understand your question. So what you ask, you have to predict the value of image, it is a good one or bad one. Okay, I have to create the make the code into the particular prediction. Once I share this, you can try with yourself, or else in the next session we have to shortly we have to discuss about the particular prediction. Okay, value 1 is missing. Of course, I can check. Yeah, here the 0 starting to 0 1 2 3 is there. How do you say this 1 is missing? You can ask said about the index or highlighted value. Sorry sir, what you said, highlighted value. Okay, so Anit Kumar sir, what you want, your exact doubt means you can ask it to a group. So I send it everything in a group. So once you check it everything and also highlight the particular missing one and share it the screenshot in image. So we will discuss about that. Okay, Sandeep sir, you got it. So I don't know where it is. $147. Okay. Okay, fine. That is having index is fourth index, right? Because of it is a less number of healthy images present in this particular index folder, then only it is getting low values. That is 147. It is a very less value. Maybe it the most disease images are present in the particular folder which happen. Yeah, of course, Amazing Grace. Yeah, exactly. There is very less amount of healthy images there. So most number of disease images may be presented here also. Yeah. Okay. Fine. Okay. So that's it. This is our day 2 concept of live disease detection. So I hope everyone understand. So once you share the code in a group, so you can try to understand this one. So if you have any doubt, you can ask in the group or next session. We can discuss about that. Right, sir. Nice, right. Okay, so thank you so much. Thank you, everyone. So next 2 days we have to discuss about the crop yield and how much yield reduction prediction based on the machine learning and also deep learning. We have to discuss about that. So once you share this, you can work with yourself, then you can understand. And thank you for listening, and kindly fill it your attendance also, so don't forget this. As usual, I have to share the everything in a group. You can work with that. Okay. Okay. Thank you everyone. Thank you for your time and listening. Okay. No issue. No doubts means no issue. If you have anyone have a doubt, you can ask anytime in a group. WhatsApp group is available. You can post that your doubt. We can clarify that. Okay. Thank you so much. Thank you all. We'll meet the next session. So tomorrow we have tried to see in a crop yield deduction, or else time based yield prediction is using machine learning. Any one project we have to try. So already one project will be error. I have to try to resolve it. Yeah, so super sir. Thank you, Akash Mishra. Thank you. Okay, thank you all. See you tomorrow. Thank you so much.